Hi everyone, welcome to our minimums and maximums video. First, we're going to talk about what a minimum and maximum actually is, and then we're going to see how to calculate that using the first derivative test and then the second derivative test, and finally what inflection points are and how to calculate them. To understand minimums and maximums, you can think about a period at MSP. So when you begin, your mood is kind of good and it increases because you're meeting your friends, going out for parties, starting learning new things. But then you realize that you have exams and you have things to do and you become stressed, so your mood kind of decreases until it comes to exams where nobody's in a good mood at all. But then your mood suddenly increases again because we have reflection week. But the point of this story is to tell you how minimums and maximums are represented in a graph. So here we have a local maximum point. I'll get back to that later. Here we have the global minimum point, and here we have the global maximum. So the difference between the global and the local maximum points is that within the whole domain we have the highest point, which will be the global maximum. But if we consider this particular region, then this point will be your maximum, so that becomes the local maximum. Whereas here within the entire graph, this is the lowest point, which is considered the global minimum. Now we're going to take a look at this function fx equals x cubed minus 3x, and it's represented in the graph on the left side. What we're trying to do here is find this maximum point and this minimum point. To do so, we need to first consider the domain of this function, because we need to see how many minimums and maximums we will encounter throughout the function. In this case, our domain is all the real numbers because there are no logs in the function and it's not divided by anything. So there are no restrictions. So we go from minus infinity to plus infinity. As you may remember, the slope of the curve at a given point is the slope of the tangent at that point. And if we consider point A and we move it towards the maximum, the slope is positive but becomes smaller and smaller until we reach the maximum point where the slope is 0. So at this point, your dy by dx is also going to be 0. And then similarly, when we move towards the minimum, the slope turns to negative. Again, as we approach the minimum, it becomes smaller and smaller until again it becomes 0. So even at your minimum point, your dy by dx is going to be 0. And as you move up the slope, again, it becomes positive. So you can see between your minimum and maximum points, it always goes from a negative slope to a positive slope. Now we're going to find the minimum and maximum points analytically. And to first do this, we need to find the derivative of our function. So f prime of x, and in this case it will be 3x squared minus 3. And as I mentioned before, at your minimum and maximum points, this will equal to 0. So then we can find our values for x. And now I'm gonna fill it in here. So we have at x equals minus 1 and x equals 1, your f prime of x is going to be 0. Now that we have found the x values for the turning points, we need to determine which one is the minimum and which one is the maximum. And to do this, we have to consider the sign around the f prime. So I'm going to take minus 2, plug it in to the equation of f of x. So we take the f prime of minus 2, which is 3 minus 2 squared minus 3, which is 3 times 4 minus 3, which is 9, and we can see that this is a positive number, so we say it's positive here. And now we're going to do the same for the points in between minus 1 and 1 and 1 and plus infinity. So the last box to consider in our table is the graph of the function, and here we can see the derivative is positive, so our slope is also positive, so it's going up. And then when our derivative is negative, means our slope is negative, and that means it's going down. And again the derivative is positive, so indicating the slope is going up. And we know that when the derivative is 0, it was a stationary point, so it means that the graph has gone up and then from that point gone down. So we can consider this to be our maximum. So at x equals 1 minus 1, it's our maximum point. And here we can see the graph has gone down and then stopped, become 0 at x equals 1 and then gone up again, indicating that at 1 it is our minimum point. If you look in the graph as well, here at x equals minus 1, you can see it is the maximum point, and then here again at x equals 1, it is our minimum point. So we just use the first derivative test to find the minimum and maximum points on a function. But now I'm going to teach you a different method of how to do that. So we had our original function, which was y equals x cubed minus 3x, and then we differentiated it to get this function. And to find minimum and maximum points, we know we have to equate it to 0, which we did previously, and found that the x coordinates will be x equals minus 1 and x equals 1. But here we still don't know at which point is it a minimum or a maximum. So to do that, we do this second derivative test, where you basically derive this equation again. So you have d squared y over dx squared, where then we get 3 times 2 times x to the power 2 minus 1, and this minus 3 becomes 0 because it's a constant, and in the end you have 6x. What we're going to do now is plug in these x values into this equation and then see if it's negative or positive. And if it's negative, it's going to be a maximum point, and if it's positive, it's going to be the minimum point. So when x equals minus 1, we do 6 times negative 1, which is negative 6. So then, because it's a negative, it's going to be the maximum. So this is a maximum point. And when x equals 1, we have 6 times 1, which is 6. So this is a positive number, and because it's positive, that means this is the minimum. So these are just, when using the second derivative, it's just to see whether it's going to be positive or negative. But the coordinates actually are determined by the first derivative. And to find the y coordinates for these points, you plug in x equals negative 1 into this original function. So y equals negative 1 to the power 3 minus 3 times negative 1. So here you have again negative 1 plus 3, which is plus 2. So the coordinates for the maximum will be at point negative 1, 2. There is another condition when your derivative equals 0 but it's not a minimum or a maximum. As you can see in the graph, which displays the function x cubed, as we move the point A, the slope is positive, and then when we reach the point 0, your derivative also equals 0. But then when we move the point higher, the slope is still positive. What we remembered from the previous video is if it's a minimum point, it has to go from change from a negative slope to a positive slope, and if we go from a maximum point, it has to go from a positive slope to a negative slope. But this is not the case for this, and that's why it's called inflection point, where we go from either a positive slope to a positive slope, which is the example in this case, or you can also go from a negative slope to a negative slope. The example we just saw was more of an exception, but usually if you want to find your inflection point, your second derivative should be 0. Your 6x is going to be 0 where x equals 0. So I'm just going to plug that in here. So when x equals 0, your second derivative also equals 0. Now to find the signs in between these two, we're going to do is select any point minus infinity and 0 and plus infinity and 0. So if we take -1, here our sign becomes negative, and if we take +1, and then our sign will be positive here. What this means is when it's displayed in the graph, that this is going to be curving like that. So here is our inflection point, and this, because it's positive, it's going to curve like this. And an easy way to remember this is if it's negative, it's going to be a sad face because it's negative, and if it's positive, it's going to be a happy face because it's positive. Find the coordinates of the inflection point is you plug in x equals 0 into your original function. So we have 0 cubed minus 3 times 0 to get your y coordinate is 0. So at your inflection point, your coordinates are going to be 0,